The BepiColombo spacecraft has just completed its fourth flyby of Mercury, delivering stunning close-up images of the scorching planet. For the first time, Earth has received images of Mercury's south pole, captured by the probe. During this flyby, BepiColombo approached Mercury from its dark side, the hemisphere hidden in the sun's shadow. As sunlight gradually illuminated the cratered surface, the spacecraft flew as close as 165 kilometers, 102 miles, above the planet, providing an astonishingly detailed view of Mercury's rugged terrain. These images are not only visually striking but also scientifically valuable, offering insights into Mercury's geology and evolution. Just 4 minutes after reaching its closest approach on September 4th, BepiColombo captured a breathtaking view of a large peak ring crater. Such craters are unique, featuring a central peak surrounded by a prominent ring rather than a single central peak. These rings form through various processes, with the inner rings potentially created by mechanisms different from the outer ones. Large craters on Mercury are the result of massive impacts from asteroids or comets, with diameters ranging from 80 to 205 miles, 130 to 330 kilometers. One of the standout craters captured by BepiColombo is the Vivaldi crater, named after the legendary composer Antonio Vivaldi. With a diameter of 130 miles, 210 kilometers, the Vivaldi crater's striking landscape was highlighted under the spacecraft's perspective, enhanced by long shadows cast near the sun's terminator. A distinctive feature of Vivaldi is a breach in its peak ring, where younger lava flows reshape this ancient basin. Moments later, BepiColombo also imaged another notable peak ring crater, Stoddard, named in honor of New Zealand artist Margaret Stoddard, celebrated for her floral paintings in the late 19th and early 20th centuries. Peak ring craters on Mercury remain a significant mystery. Scientists believe their formation involves a rebound process during impact, but questions linger about how deeply the uplifted material originates beneath the surface. The images from BepiColombo's flyby are among the most detailed yet, showcasing Mercury's surface scarred by 4.6 billion years of asteroid and comet bombardment. Each crater on Mercury tells a tale of the planet's tumultuous history. Remarkably, these stunning images are not part of the primary mission of BepiColombo's MCAM cameras. Originally designed to monitor the spacecraft's status during critical post-launch phases, these cameras capture black and white images at a resolution of 1024 by 1024 pixels, but have exceeded expectations. However, the real highlight lies ahead. BepiColombo's main science cameras, currently shielded for protection during its journey, will provide higher resolution images once the spacecraft enters Mercury's orbit, promising even more detailed insights into the planet's enigmatic surface. Launched in 2018, BepiColombo is expected to enter Mercury's orbit in November 2026. This extended journey often raises questions. Why does it take so long to reach Mercury, while spacecraft like Cassini took a similar time to reach Saturn, which is billions of miles farther away? The answer lies in 3 significant challenges that make reaching Mercury particularly difficult. First, the spacecraft must significantly reduce its initial velocity. When BepiColombo left Earth, it carried the momentum from Earth's gravitational pull, resulting in high velocity. To be captured by Mercury's weaker gravity, the spacecraft must decelerate through multiple flybys and complex maneuvers. The second challenge is the Sun's gravitational pull. Since Mercury orbits very close to the Sun, BepiColombo is constantly being drawn toward the star. A direct flight to Mercury would require an enormous amount of fuel to decelerate enough to avoid falling into the Sun. The final challenge is temperature. As it approaches the Sun, BepiColombo must endure extremely high temperatures. Advanced cooling and shielding systems are critical to protecting the spacecraft's sophisticated instruments. BepiColombo's journey to Mercury is marked by several key flybys, each adjusting its trajectory and velocity. The first milestone was the Earth flyby on April 10, 2020, which directed the spacecraft into the inner solar system in preparation for subsequent flybys of Venus. During the Earth flyby, BepiColombo came within 12,000 miles of the planet, reducing its speed relative to the Sun by approximately 3 meters per second. This maneuver saved around 450 kilograms of fuel, crucial for ensuring the spacecraft has enough energy for the long journey ahead. On October 15, 2020, Beepy Columbo conducted its first Venus flyby, a significant step in refining its trajectory to approach Mercury. Using Venus's gravity, the spacecraft adjusted its velocity and direction, conserving energy while maintaining its precise course. This flyby served as a critical stepping stone for the second encounter with Venus. On August 10, 2021, Beepy Columbo executed its second Venus flyby, further fine-tuning its trajectory. This time, the spacecraft recorded a unique phenomenon, the sound of solar wind at Venus as it passed just 340 miles above the planet's surface. Using its magnetometer, Beepy Columbo captured the interaction between the Sun's charged particles and Venus's dense carbon dioxide-rich atmosphere. This sound is not audible in space, but is a form of sonification, converting data into sound, providing a rare glimpse into the complex interplay between solar wind and Earth's closest planetary neighbor. On October 1, 2021, Beepy Columbo completed its first Mercury flyby, coming within just 125 miles of the planet's surface. This marked a critical milestone in the mission, as the spacecraft gathered detailed images and valuable geological data about Mercury. This was the first of 6 planned flybys, essential for adjusting the orbit as the spacecraft approaches its final destination. On June 23, 2022, Beepy Columbo completed its second flyby, this time coming as close as 120 miles above Mercury's surface, capturing additional images and further reducing its speed to prepare for the next phase. The third flyby took place on June 19, 2023, when the spacecraft passed within 147 miles of Mercury's surface, incrementally adjusting its velocity to ensure readiness for orbital insertion. Initially, Beepy Columbo was scheduled to enter Mercury's orbit in December 2025. However, on May 15, 2024, the European Space Agency (ESA) announced a technical issue during a critical maneuver. A malfunction on April 26 prevented the spacecraft's thrusters from operating at full capacity, impacting the mission timeline. By September 2, 2024, ESA confirmed a corrective trajectory plan to address the issue. This adjustment, necessitated by the reduced thruster power, extended the mission by 11 months. Consequently, the spacecraft's expected arrival at Mercury was postponed from December 5, 2025 to November 2026. This delay ensures Beepy Columbo can safely complete its mission despite unexpected challenges. Beepy Columbo is expected to answer many unresolved questions about Mercury, one of the least understood planets in the solar system. A major mystery is Mercury's magnetic field. While Earth and Mercury are the only rocky planets with magnetic fields, Mercury's is significantly weaker. Understanding how Mercury maintains its magnetic field, despite its small size, could provide critical insights into planetary magnetism and the evolution of other planets. Another enigma concerns Mercury's unusual density. The planet has a large iron core comprising about 85% of its radius, sparking various hypotheses about its unique formation process. Beepy Columbo will investigate how this core formed and whether Mercury underwent a distinct evolutionary process, shedding light on planetary formation more broadly. Mercury's surface composition and geological history also remain a puzzle. Beepy Columbo will explore the history of volcanic activity, surface tectonics, and the mysterious hollows scattered across the planet's surface. Finally, Beepy Columbo will study Mercury's thin atmosphere and its interaction with the solar wind, offering a better understanding of how planets without significant atmospheres behave under solar radiation. These findings could reshape our knowledge of Mercury and the inner solar system, providing deeper insights into one of the most enigmatic planets. The challenging journey and promising discoveries of Beepy Columbo exemplify humanity's relentless pursuit of exploration, bringing us closer to unraveling the secrets of the cosmos.